fact about this topic is that the types of questions you will see are very few and repetitive. One category is that of forming numbers. We will be given a few digits and will be asked to form numbers. For example, with these 6 digits, we could be asked of how many 3-digit numbers we can form. Next, we might be asked to form anagrams. Here, we will be given a word like silent, and asked for the number of anagrams we can form with these 6 letters. An anagram of a word can be formed by simply rearranging its letters. An anagram of silent would be listen. Another anagram would be ESITLN. What does it mean? Nothing. It's a meaningless anagram. It won't work in Scrabble. Another category of problems would be that of arranging people. We could be asked the number of ways in which we can seat people on 4 chairs, or maybe arrange them around a circular table. So in this session and the next few, we will be looking at the first category, arranging digits to form numbers. Let's say we have these 5 digits with us, and this is what we're asked. Read the question well. How many 3-digit numbers can be formed? Let's form 3 slots here for the 3 digits. How many 3-digit numbers can we form using these 5 digits? And with this question, we have been given 2 conditions. First, it asks us the answer when repetition is not allowed. Let us understand the first condition. Repetition is not allowed. Look at the number 111. This is a 3-digit number, but the digit 1 is repeated. Look at 232 or 544. The digit 2 is repeated here, and the digit 4 is repeated here. By repetition not being allowed, they mean that numbers like these should not be considered. Each of the digits in the slot should be different. So numbers like 123, 341 or 524 are allowed as the digits in each case are different from each other. So let's make 3 slots for the digits again. Now you can start thinking. How many 3-digit numbers can be formed if repetition is not allowed? Before you think of the 3-digit numbers, look at the slots individually. Let's look at the first slot or the hundreds place. In how many ways can you fill the first slot? It is a simple question. You don't need to know permutations or combinations for this. In how many ways can you fill the first slot? You can fill it with any of the 5 digits, right? You can fill it with a 1 or a 2 or a 3 or a 4 or a 5. These are the 5 digits given to us. Did you listen carefully? I used the word or. 1 or a 2 or a 3 and so on. So 5 ways in all. We can fill it with any one of these 5 digits. Okay, now listen to the next question carefully. Having filled the slot with one of the digits, in how many ways can we fill the second slot? Easy. We have used one of the digits here. It can be any digit, doesn't matter. But after having used 1, 4 digits remain. So the second slot can be filled in 4 ways. If we fill the first slot with 1, we have 2, 3, 4, 5 as possibilities here. If we fill the first slot with 3, we have 1, 2, 4, 5 as the possibilities for the second slot. Now tell me, having filled the first and the second slot, in how many ways can the third slot be filled? It's simple. We have used up 2 digits here. Only 3 remain. The third slot can be filled in 3 ways. We're almost done. Almost. The first slot can be filled in 5 ways, the second in 4 ways, and the third in 3 ways. So how many 3-digit numbers can be formed if repetition is not allowed? Do we add these 3 or do we multiply them? What are we doing? Are we filling in the first slot or the second slot or the third slot? Or are we filling in the first slot and the second slot and the third slot? It will be and. Yes, we are filling all 3 slots and not just one. And as we have seen in the previous session is multiplication. So we multiply these 3. 5 times 4 is 20 and 20 times 3 is 60. There are 60 ways in which we can form 3-digit numbers without repetition of digits. These include numbers like 123, 314, 245 and so on. No repetition. Hope this was clear. Here we started off with the hundreds place. Can we start off with the units place? Of course yes, we could have. If we would have started off with the units place, we could say that the units place could be filled in 5 ways. Once the units place is filled, the tens place would be filled with any of the remaining 4 digits. And once 2 digits are utilized, the hundreds place can be filled with any one of the remaining 3 digits. 3 times 4 times 5 will also give us the same answer, 60 ways. If you really understood this, then understanding the second stated condition would be super easy. Let's repeat the question on a new page. This time we solve the question keeping in mind the second condition. Given these 5 digits, how many 3-digit numbers can be formed assuming repetition is allowed? So now we are allowed to consider numbers like 111 or 322 and so on. So we have 3 slots for the 3 digits. How many 3-digit numbers can be formed when repetitions are allowed? I want you to try this. Remember, repetitions are allowed. So now we are allowed to consider all numbers which we had ignored earlier. We should have the possible numbers greater than 60. Try it. Okay, as we saw earlier, let's go slot by slot. In how many ways can the hundreds place be filled? It can be filled with any one of the 5 digits we have. It can be filled in 5 ways. Now in how many ways can the second slot be filled? Think well. The second slot can also be filled in 5 ways. Why? It's because repetitions are allowed. If we used up 1 digit here, the same one can be used here as well. So no matter what digit is used in the hundreds place, the tens place can be filled with any one of the 5 digits we have been given. And similarly, the third slot can also be filled with any one of the 5 digits. 5 ways again. If we have 1 in the hundreds place, the same one can be used in the tens place and in the units place as well. There are no restrictions here. So as we are filling in the first and the second and the third slot, we multiply these 3 numbers and get the answer as 125 ways. What does this answer imply relative to the previous one? Let's go back and see the previous answer. If repetition wasn't allowed, there were 60 ways in which we can form 3-digit numbers. And if repetition is allowed, there are 125 ways. Why has the number increased? It's obvious. Here, apart from the no repetition ones, like 123, 314, 245, we have allowed numbers like 111, 222, 434 and many more like them to be considered. So I hope both cases are clear. Repetition allowed and not allowed. Which case do you think is easier to solve? Think. It is the repetition allowed case. We don't have to worry about any of the conditions given. It makes life really easy and you will realize why when you watch the further sessions. We have been given 5 digits, 1, 2, 3, 4 and 5. And along with that, we have this question. Using these 5 digits, how many 3-digit odd numbers can we form? First case, when repetition is not allowed, and second, when repetition is allowed. By repetition not being allowed, they mean we cannot consider numbers like 131 or 224 which have repeated digits. Let's understand the first part. Read the question well. How many 3-digit odd numbers? Odd is the key word here. As we have been asked for 3-digit numbers, let's make 3 slots. What do we mean by odd? A number is odd if it is not divisible by 2. Is 342 odd? No, it's not odd as it is divisible by 2. What about 531? Is this odd? Yes, it is, because it is not divisible by 2. Similarly, 325 and 243 are odd. In simple words, this 3-digit number will be odd if its unit digit is odd. So based on the condition we have, the 3-digit number can end with a 1, or end with a 3, or end with a 5. Correct? These are the only 3 possibilities here. Now focus on the first possibility. The number ends with a 1. In how many ways can we fill the first slot or the hundredth slot? What do you think? The digit 1 is gone, so the hundredths place can be filled with any one of the remaining 4 digits, 2, 3, 4 or 5. 4 ways in which it can be filled. What about the second slot? The digit 1 is gone and another digit out of these 4 is gone into the hundredths place. Only 3 digits remain. So the second slot can be filled in 3 ways. With 1 in the units place, and as we are filling the first and the second slot, we multiply this. And is always multiplication. 4 times 3 is 12. Given these 5 digits, there are 12 ways in which we can form a 3-digit number with 1 as its units digit. Are we done? No, we still have to look at these 2 cases. In the second case, the digit 3 is gone. The first slot can be filled with 1 or a 2 or a 4 or a 5. 4 ways. As 2 digits are gone, the tens place can be filled in 3 ways. Again, as we are filling the first and the second slot, we have a multiplication sign here. Given these 5 digits, there are 12 ways in which we can form a 3-digit number with 3 as its units digit. And similarly, we get a 12 here as well. Let's zoom out slightly. What do we do with these 3 numbers? Do we add them or multiply them? To know the answer, just use plain English. The units digit is 1 and 3 and 5? Or should we say that the units digit can be 1 or 3 or a 5? Of course, it's an or. Based on the condition given, the units digit can be 1 or 3 or 5. And or implies plus. Adding these 3, we get the answer as 36 ways. 36 ways in which we can form 3-digit odd numbers using these 5 digits. Now this was slightly long and a more logical way of solving this. Now that we know the concept, let's look at a quicker way to solve it. We know it is a 3-digit number. What is the condition given to us? The condition is that the number should be odd. Remember a golden rule. Whenever we are given a condition, start with it. As the condition is about the numbers being odd, we can be sure that it depends on the units digit. So we start off with the units digit slot. In how many ways can we fill this slot? It can be filled with a 1 or a 3 or a 5. 3 ways. Now we can move on to the other 2 slots. 1 digit is gone. It doesn't matter what digit it is. If 1 digit is gone, then 4 remain. The hundredths place can be filled in 4 ways. If the units digit is filled with 1, any digit from 2, 3, 4 or 5 can be in the hundredths place. If the units digit is filled with 3, any digit from 1, 2, 4 or 5 can be in the hundredths place. And when 2 digits are used for the hundreds and the units place, just 3 remain. The second slot can be filled in 3 ways. And we multiply these to get the answer, 36 ways. We got the same answer, but a lot quicker. Some of you would be thinking, why start with the condition? What if we don't? Let's say we decide to start with the hundredths place. In how many ways can we fill the hundreds place digit? We can fill it with any of the 5 digits. 5 ways. Having used one digit here, the tens place can be filled in 4 ways. And now we come to the units place. In how many ways can we fill the units place? Can we say 3 ways as 3 digits are left? Maybe not. Let's say we used a 1 here. We have 2, 3, 4 and 5 left. Say I pick a 3 here. Now, in how many ways can the units digit be filled? It has to be odd. The only odd digit that remains is 5. It can be filled in just one way, and that's 5. Let's take another scenario. Say we filled the hundreds place with 2 and we picked a 4 in the tens place. Now tell me, in how many ways can we fill the units digit? 1, 3 or 5. All will keep the number odd. In this case, there are 3 ways in which the units digit can be filled. So we end up with conflicting answers if we don't start with the condition. When forming numbers, remember to start with the condition. There are 36 ways in which we can form 3-digit odd numbers using these 5 digits if repetition is not allowed. And what if repetition is allowed? Remember, life becomes really easy if repetition is allowed. Let's solve it on a new page. Using these 5 digits, how many 3-digit odd numbers can be formed if repetition is allowed? Okay, let's solve the second part. We are talking about 3-digit numbers here and they have to be odd. Let's start with the condition. In how many ways can we fill the units digit? As the number has to be odd, we can fill the units digit with either a 1 or a 3 or a 5. 3 ways in which the units digit can be filled. We are done with the condition. In how many ways can we fill the hundreds place now? What do you think? As one digit is used here, the hundreds place can be filled in 4 ways, correct? No, it's not. Don't forget, repetition is allowed. We can use the same digit here as well. 5 ways in which the hundreds place can be filled. Any one of the 5 digits. And what about the tens place? Again, it can be filled with any one of the 5 digits. 5 ways. As we are filling the first and the second and the third slot, we multiply these numbers. We get the answer as 75 ways. There are 75 3-digit odd numbers we can form using these 5 digits if repetition is allowed. Here's my last question in this session. If repetition is allowed, do we have to start with the condition? Let's say we start with the hundreds place. It can be filled with any of the 5 digits. It will be the same with the tens digit as repetition is allowed. And the units digit again can be filled in 3 ways. The answer does not change even if we start with the hundreds place. If repetition is allowed, we don't really have to start with the condition. Don't stress yourself out by having to remember this. As a general rule, just start with the condition. That's how we deal with numbers with a condition. We will cover a few more interesting examples in the coming sessions. 1, 2, 3, 4 and 5 are the 5 digits given to us. And we have been asked this. How many 5-digit numbers can be formed using these 5 digits? And we need to figure this out for 2 cases. When repetition is not allowed and when repetition is allowed. If you haven't already, I strongly recommend that you go through our previous sessions based on forming numbers. It will help you understand the session much better. Okay, let's understand what's been asked. In the first case, we have been asked to find the number of ways in which 5-digit numbers can be formed when repetition is not allowed. Okay, first things first, let's make 5 slots for the 5 digits. Is there any condition given? No, there isn't. We have been asked for all 5-digit numbers that can be formed using these 5 digits. As there is no condition, we can start from any end. Let's start with the first slot. In how many ways can the first slot be filled? we can fill it with any one of the 5 digits, correct? Yes. So there are 5 ways in which it can be filled. Either a 1 or a 2 or a 3 or a 4 or a 5. Now assume we have filled up the first slot with one of these digits. With the first slot being filled, in how many ways can the second slot be filled? As one digit is used here, 4 remain. The second slot can be filled in 4 ways. If the first slot is filled with a 4, then the second one can be filled with 1, 2, 3 or 5. If the first slot is filled with a 2, then the second one can be filled with a 1, 3, 4 or a 5. Now as 2 digits have been used in the first 2 slots, the third one can be filled in 3 ways. Similarly, the fourth one in 2 ways and the last one is just 1 way. Do we multiply these or do we add them? Don't forget the basic rules of counting. OR is addition and is multiplication. As we are filling the first and the second and the third slots and so on, we will be multiplying these. 5 times 4 is 20, 20 times 3 is 60, and 60 times 2 is 120. There are 120 5-digit numbers that can be formed using these 5 digits, provided repetition is not allowed. This is actually 5 factorial. Many students memorize this. 5 distinct things can be arranged in 5 factorial ways. Don't make that mistake. Yes, you may use 5 factorial directly, provided you understand why we use the factorial. Here, we saw it step by step. Why 5, why 4, and why we multiplied them. Don't memorize the factorial formula. Understand the logic behind it and then use it. Now let's move on to the second part. 5-digit numbers when repetition of digits is allowed. So we are allowed to form numbers like 11111 or 52333 or 31443 where digits are repeated. How do we begin? As always, we go slot by slot. The first slot can be filled with any one of the 5 digits. It can be filled in 5 ways. Now I want you to answer the next question. Having filled the first slot with any one of the digits, in how many ways can the second slot be filled? As repetition is allowed, it doesn't matter which digit we have filled in the first slot. The second slot can be filled in 5 ways again. Why was it 4 in the previous case? Because we cannot reuse the digit that was used in the first slot. In a similar way, the third, fourth and the fifth slots can also be filled in 5 ways each. And we multiply these as we are filling the first and the second and the third slots and so on. We get the answer as 5 raised to 5 ways. We can form these many 5-digit numbers using these 5 digits, provided repetition is allowed. These problems are easy, provided you understand the logic of repetition. Let's look at one last question. In how many ways can 6 seats be allocated to 6 people? Assume that the 6 people are A, B, C, D, E and F. And imagine 6 chairs in a row where these 6 people will be seated. How will you solve this? In how many ways can these 6 people be seated on these 6 chairs? Pause the video and try solving it. Think logically. Isn't this the same as having 6 different digits and being asked how many 6-digit numbers can be formed? Of course, without repetition. 6 different people are analogous to 6 different digits. Each number formed will be analogous to each arrangement formed. And it is obviously without repetition, as one person cannot be seated on 2 or more seats. If one person is seated on chair 1, he cannot be seated on chair 2 as well, right? And what will the answer be? Let's go back to the previous page. 5 digits in 5 slots when repetition is not allowed is this case. 5 factorial. Going back to the current problem, The answer to it will be 6 factorial. 6 people can be arranged on 6 seats in 6 factorial ways. Here, we have assumed that the seats are in a row. The answer will be different if the seats are arranged in a circular fashion. Don't worry about it for now. We have covered circular arrangements in another session. Just like what we have seen in the previous sessions, we play with these 5 digits. And here's our question. Take a moment and read it well. Using these 5 digits, how many 3-digit numbers greater than 200 can be formed? Let's read it again. 3-digit numbers greater than 200. And again we have 2 cases, when repetition is not allowed and when it's allowed. Let's understand the first case. We have to form 3-digit numbers, so we make 3 slots for each of the digits. Read the question again. Do we have a condition here? Yes, the condition is that the 3-digit number must be greater than 200. And we have seen before that if we have a condition, we always start with it. It means we start with the hundreds place. This is a golden rule. If you're given a condition, always start with it. Now ask yourself one simple question. If the number has to be greater than 200, then in how many ways can the hundreds place be filled? Don't forget, we can use only one of these 5 digits. Think, it's easy. If the number has to be greater than 200, then the hundreds place should have a digit greater than 2. So we can fill the hundreds place with a 3 or a 4 or a 5. In 3 ways, correct? This is a very common mistake that students do. It's incorrect. The hundreds place can be filled with a 2 or a 3 or a 4 or a 5. Even 213 is greater than 200. 245 is also greater than 200. The only number that will not be greater than 200 when 2 is in the hundreds place is 200. But here, 0 is not one of the 5 digits. So we don't have to worry about that special case of 200. There are 4 ways in which the hundreds place can be filled. With a 2 or a 3 or a 4 or a 5. Not a 1 as the number has to be greater than 200. Now we move on to the next slot. Assuming we have filled the hundreds place with one of these 4 digits, in how many ways can the tens place be filled? Think carefully. 1 digit is used here. In how many ways can we fill the second slot? As 1 digit is gone, 4 remain. Simple? The second slot can be filled in 4 ways. If we use a 4 here, then 1 among 1, 2, 3 and 5 can be used here. If we use a 2 here, then 1 among 1, 3, 4 and 5 can be used here. So having used 1 digit in the hundreds place, the tens place can be filled in 4 ways. Now having used up 2 digits for the hundreds and the tens place, in how many ways can the units digit be filled? As 2 digits are used, obviously 3 would be left. It can be filled in 3 ways. We are filling the first and the second and the third slots. So we multiply these numbers. The total number of ways would be 4 times 4 times 3. It equals 48 ways. And what is this 48? It is the number of different 3-digit numbers greater than 200 that can be formed using these 5 digits. But when repetition is not allowed. Will the answer change if repetition is allowed? Let's move to a new page. We try to answer the second part here. Using these 5 digits, how many 3-digit numbers greater than 200 can be formed if repetition is allowed? We make 3 slots to represent the 3 digits. In how many ways can we fill the hundreds place? As the number has to be greater than 200, we can fill it with a 2 or a 3 or a 4 or a 5. 4 ways. Okay, good. Now answer this question. Having used up 1 digit here, in how many ways can we fill the second slot? So after having used up one digit here, does it mean that there are just 4 ways in which you can fill up the slot? No, it does not. Repetition is allowed. If we use a 3 here, we can use it again in the tens place. The number of ways in which the tens and the units place can be filled is independent of the condition, as repetition is allowed. The second slot or the tens place can be filled with any one of the 5 digits we have. It can be filled in 5 ways. And with the same logic, even the units place can be filled in 5 ways. Why 4 ways for the first slot? Because we cannot fill it with a 1. The number has to be greater than 200. We multiply these numbers as we are filling the first and the second and the third slot. 4 times 5 is 20 and 20 times 5 is 100. 100 ways is the answer. We can form 100 3-digit numbers greater than 200 using these 5 digits when repetition is allowed. Do we have to start with the condition when repetition is allowed? Nope. When repetition is allowed, we can start off with any of the slots. We will get the same answer.